we thought of the bone marrow as producing the cells for the blood. So when you go to medical school in 1980, they would teach you that you use your bone marrow to make blood cells. So you make white blood cells and red blood cells and so on. And we produce blood cells that go out into the circulation to do what blood cells do. And it sort of ended there. But what we came to realize much later than that is that stem cells are related in some way to some of these blood cells. They follow what are called similar bloodlines. So it is not surprising in a way that stem cells did eventually be proved to originate in the bone marrow. The bone marrow is like a factory for making new cells. And some of these cells that it makes are stem cells. And these stem cells are released from the bone marrow. They go into the circulation. They literally travel throughout the body. And on demand, I say on demand because when tissues are injured, the injured tissues release what are called chemokines. Now, you don't have to remember this because no exams are involved here. So just take it from me that there are some special chemicals that injured tissues release. We've known that for a long time because of what's called the inflammatory response. If you sit in the bathroom and you put your elbow on your knee, after a few minutes, you get up, your knee's red. Why is it red? Because you put pressure on the tissue, and the tissue, sensing the pressure, release some factors, some chemicals. And these chemokines literally cause what is called an inflammatory response. And the inflammatory response brings blood vessels, so you see red, and these vessels create a whole, I was going to say a multitude of reactions that are very well studied, very well understood today. That inflammatory response is just one example of what happens. It's the same thing that happens in so many different challenges to the body. The body responds. When the tissues are injured, they release these particular molecules that go to the bone marrow to give the bone marrow a signal. We need help. Because we need help, the bone marrow then says, okay, help is on the way. It releases stem cells. The stem cells go out into the circulation, and as they circulate, just as they are passing the tissues that are injured, the tissues set out some chemokines again and simply say, hey, come here guys, come here, we need you right here. So they then migrate into the specific tissues. And as these stem cells get into those tissues, they begin to effect their work of repair and renewal and rejuvenation and healing. So here's the key. Release from the bone marrow, circulate in the bloodstream, migrate into the tissue, and get busy. This we now call the normal stem cell theory of renewal. More and more evidence has come about over the past 10, 12 years to verify how valuable a theory this is. And I will just give you some, I think on my next slide, I talk about some of the evidence. Now this could get technical if I'm not careful, so let me just simply say this. There are different ways to prove what I just said. And there are three particular lines of research that justify all that I just said. There is a particular protein called green fluorescent protein. This protein is so important that a guy got a Nobel Prize for discovering this. This green fluorescent protein is fluorescent. And because it's fluorescent and green, you could see it where it is. So here you have a protein that you could see because it fluoresces green. This protein can be used to tag cells, and as the cells move, you could see the green fluorescence. So you know where the cells go, right? So what has happened now is we're able to follow the movement of cells in a very sophisticated way. And studies using green fluorescent protein have demonstrated that if, for example, you were to just inject stem cells into let's take a mouse. A mouse is a good model for a human being. So let's not treat people just yet. Let's start with mice. Just inject mice with cells, stem cells, labeled with green fluorescent protein. The mice has no fluorescence. You now give it cells with green fluorescent protein. So you could follow what happens to those cells. Lo and behold, just wait, and you will notice that many tissues in the body start to light up with green fluorescence. Why? Because these stem cells, after injection, have circulated, got to the tissues needy, multiplied, differentiated, and actually started to become cells of the various tissues. And it goes even to the brain, the bone, the liver, the spleen, the lungs, the kidneys, and so on, the skin. That's a very simple thing. Second one, then it's sex mixmatched transplantation. What's that? Well, you can have, all of you, I think, know the birds and the bees. You know that women have XX chromosomes and men have XY. Suppose you want to do a liver transplant. And you took a transplant from a male mouse and you put it in a female mouse. The male mouse would now have Y, but it's only in the liver when you put it in there. And you just wait, and lo and behold, let's not take the liver. Let's start with the bone marrow. Let's go one step at a time. Let's take the bone marrow first. Take bone marrow from a male mouse, XY, and put it in a female mouse. And then, as the XY stem cells leave the bone marrow, you could see what happened to the XY stem cells. And lo and behold, you could see them leave the bone marrow, go out into the tissues, and penetrate the tissues to do exactly what I just said. A third way to do it is to use fluorescence in situ hybridization. Nice technical term, all it means is this. You could literally tag different types of tissues with the fluorescent molecules of different types, and you can literally, again, follow the course of stem cells as they leave from one particular part of the body to another. Bottom line is this. I don't want to bore you with the technicality, but I want to make sure you understand that there are different lines of research that justify today unambiguously that what I just described as the normal stem cell theory of renewal has now been fairly well established. And more evidence continues to come in to verify this. That normal adults, you don't have to be sick, you don't have to have a disease, you don't have to be aged, you don't have to be anything. Normal adults, we've showed it for us in mice, now we've showed it in human beings. Normal adults are constantly releasing from their bone marrow stem cells that exist in every human being. They go out into the circulation, they circulate through the body, and where there are tissues in need, they migrate in to effect repair. They begin to differentiate to become cells to replace injured cells and so on. This has major implications, as I will show you. Now, here it is in a diagrammatic way. And all that tells you is that the bone marrow releases stem cells circulate, and they become cells of liver, of muscle, of heart, of the brain, and so on. By the way, for a long time, I mean like decades, many generations actually, we thought that the brain would never renew itself. We thought that you were born with a certain number of brain cells, that was it, good night. Today we now understand that's not true. Stem cells get to the brain. Stem cells regenerate neurons and glial cells, which is essentially the matrix of the brain. That's what cells do, stem cells in particular. And all the cells of the body fall into that same category. Now, I have summarized all this in a way that I like to say it. So I'm just going to try to say it to you because this keeps me, it makes it very easy for me. Here's the reality. Everybody has stem cells. Everybody. Everybody in this room has stem cells. Everybody you know has stem cells. Everybody lives next to you has stem cells. Everybody in your family has stem cells. Everybody you've ever known had stem cells. Everybody has stem cells. Everybody uses stem cells. While we are sitting here right now, we're all using our stem cells. If we could take a sample of our blood right now, we could actually demonstrate that in your blood, right now, there are stem cells, and you're using them because they're circulating, going into tissues that have need. So if today you stumped your toe, if today you had a problem in your liver, if today you had something in your thymus go wrong, they're going around the body looking for tissues in need and literally going there to start that process and to aid in renewal. Everybody has stem cells. Everybody uses stem cells. Everybody uses it every day. That is to say, it's not when you're sick. It's not when something happened to you of any kind. Every single day, every single person, every single time. Everybody uses stem cells. Everybody has stem cells. Everybody uses stem cells. Everybody uses it every day. And stem cells work. Because that's how we stay alive. We stay alive in part because our stem cells are constantly at work renewing our tissues, keeping us healthy, maintaining our health. It's a constant internal renewal. And they work every time. And the reason I added that is this, very important. We doctors like to take credit for what we do. So somebody's got a fever, and we give them some antibiotics, and the fever go down, and the white cell count go down, and they do better, and they put a smile on their face, and they get back their energy. Yeah, look what we did. We love that. We love somebody comes and they got a fracture, and you put them in a cast, and you keep it. 6 weeks later, they take off the cast, they start to move their limbs, and bang, not a sign of fracture. Wow! Not to talk about emergency and major surgery and all that sort of stuff. We doctors love to do that. But have you ever thought that most of what happens in your body has nothing to do with the doctor? Did you have supper tonight? Let's listen to this for a second. You had supper tonight. There is no gastroenterologist in the entire world who could help you do what you are doing right now. You took food. All of you took different kinds of food. You put it in your mouth, you chewed, you swallowed, and that's it. Your work is done. Now look what happens. That food has gone on a mission. It goes into your alimentary canal, into your digestive tract. Every single molecule of that food knows exactly where it's destined. Every single molecule is treated in a unique way to get across the intestines into the blood, to circulate, to find the tissue it is destined for. And then something else, all the enzymes that work on it, and literally that same food, some of it becomes skin and bone and tissue and hair, without any doctor involved. And that's the normal physical activity of the human body. You'll go to sleep tonight. No cardiologist in the world can keep your heart pumping. You'll go to sleep, and somehow or other, some cells know exactly when to trigger, and they fire a signal, and it goes down some nerves, and these nerves know exactly when to go across the synapse, the signal, to the muscle. The muscle knows exactly when to contract, and the valves know exactly when to open, and everything just keeps happening without any participation from medicine. I want to give you a sense, because this sense, to me, is so vitally important. You'll almost stand in awe of your physical body every single day, just amazed at how you're even staying alive. You go to sleep, and your body just spontaneously breathes. You know exactly how fast, how much. When you breathe, the oxygen goes down into your lungs, and it knows exactly how to attach itself to the hemoglobin, how to travel along, how to release it into tissues, how to generate more energy, how to get your brain working. All this is happening spontaneously. This is nature. Stem cells fall into the same category. I want to give you this emotion, this very important sense. That's why I'm spending time on it. You have to appreciate that your stem cells are spontaneous agents. They're happening. Everybody has stem cells. Everybody uses stem cells. They use them every day. They work, and they work all the time. So where does stem cell nutrition come in? Well, here's a new wellness paradigm. What does that mean? Everybody wants to stay healthy. Everybody wants to live a long life. Everybody wants to stay young and vibrant and have energy and have their cognition and a good memory and live a long and healthy life. And so we speak in terms of wellness. And we talk in terms of staying healthy and being healthy and vibrant. And there's so many different paradigms for this. Well, here's a paradigm. Here's a paradigm. The paradigm is one of this, taking the stem cells as the key. If your stem cells are the natural, normal renewal process, anything that seems to support the stem cells, enhance the stem cells, work with the stem cells, is a way of, in a sense, enhancing that renewal process. And so now we come to the whole concept of using stem cells to improve your normal physical condition. This is a new wellness paradigm. I'll come back to that in more detail. Let me just simply tell you that in the old days, I call it the old days, I spent 35 years in the old days. For 35 years, I have been involved in this whole wellness exercise. That's why I got into medicine. I started off from chemistry to vitamins, from vitamins to the interface, from the interface into medicine. When I got into medicine, I went to medical school thinking all the time, why do people get sick so often? Why do they stay sick so long? And so my whole orientation was one of wellness. And the concept of wellness, for me, for years, and I'm talking about 35 years, was summarized here. Give the body the tools. And as I used to say, let's supply the troops. Give them vitamins. Give them essential fatty acids. Give them herbal products. Give them fiber. Give them antioxidants. Give them digestive enzymes. Even have nutrition, nutrient delivery systems for them. Support the troops. And if you keep the troops fighting and keep them vibrant, you're going to win. The reality is, now I come to understand, and I only came to this when I came to stem cells. Because stem cells goes one step further. Imagine a battle where you're supplying the troops on the front lines with all the resources they need. Sooner or later, they tire, they get injured, they die. Then what? Here's the alternative. In fact, it's not even an alternative. It's probably something that you need to do in addition, and probably perhaps more importantly. And that is, instead of just supporting the troops, we now need to think of sending in some firecrack Marines, constantly supplying brand new Marines to go to the front lines to continue the battle. And in a sense, that's what stem cells do. They're able to come in and support the tissues you need to provide brand new, fresh, cracked, healthy cells that in a sense are the frontline troops. So cells are at war, we must fight it in the right way. I have summarized this in what I call my 4P wellness paradigm. Here it is. Number one is to put the focus on personal responsibility. What I just said has so little to do with the doctor that you can't wait for the doctor to do this for you. When it comes to wellness, of enjoying the best of life and the most of life, you've got to take responsibility. Why? Because it's what you do between your visits to the doctor that's so important. Personal responsibility. Secondly, a focus on prevention. That is to say, I don't want to wait